All right, so welcome back from the break. And I think we can start with our next very interesting talk about ROS and robotics. And this one comes from Universal Robots, from Michal, who's going to present about ROS2 and how it can be integrated into URScript. So thank you for being here. And yeah, let's watch and see what great stuff you had prepared for us.
Yes, so welcome. My name is Michal Milkowski. I represent a small backend team in Universal Robots that is working with the controller. And a while ago, we decided that it would be nice to integrate ROS2 in URScript. So here we are. It's not completely done, but you will get some nice sneak peek. So this is what we can do today. We have a UR robot and we have a UR ROS driver. It's not only ROS2, it's also ROS driver and certain ROS application that is, which is like motion planning, move it, something that can that wants to control the robot, and the robot is kind of degraded to the 6-axis actuator in this setup. What we have recognized for a couple of years in UR is that programming a robot from our interface, graphical interface, is fairly easy. So, you can do many applications that way. But some advanced applications where people want to use ROS are not possible, or at least it's very hard to do that. So we still would like in this new setup the UR robot to be more than a 6-axis actuator, to be actually the controller of the work cell, but to work directly with the ROS applications that are written for more advanced tasks. So the idea is that we have a UR robot that directly communicates with ROS nodes. One of the main motivations is that we also want to provide a more unified interface for our URCAP developers. I will come back to that a little bit later, but we would like URCAP developers to switch their way of communicating their backend solutions to use ROS2 as a unified communication channel. And the ROS2 driver will still be supported for, I presume, many years in the current form. So we have prepared a small chat session, you can say, where you could, we would like to leave, if you're interested in that topic, and if you're interested that if we could contact you, talk about your use cases after this ROS industrial days, then you could leave your email in that chat. It's all will be visible only to us, so it's not a public chat. And then there is also a QA that will be that you can ask questions like that we can answer offline beyond this session. So yes, please log in. I will show that QR code like a couple more times during the presentation. Going forward, we decided that it would be nice to use ROS as the unified communication interface. And the way we want to integrate it is that our software runs something that is called the URScript, which is controlling the robot motion and interacting with external equipment. We also have a URCAPs running on the robot, and we have few internal projects that are right now using ROS as a communication interface. So our main motivation, as I said, was URCAPs, so making it easier for URCAP developers to use all our interfaces. This is a long-term plan. We are implementing right now just the first phase. Nevertheless, it will be already possible in the first version to use that to use ROS communication. And then we would like to also leverage this like a big ecosystem of ROS components. There are many algorithms, drivers for hardware, protocol converters in ROS that could be used. it's not exactly an app store type of a thing, but they can be fairly easily integrated in the system, much easier than writing things from scratch. And have a nice dream of making it much easier to deploy multiple robots in a cell that are coordinating operations between each other in a kind of a more seamless way for the robot programmer. To realize that, the hardware, the software setup below is based on the Dockers. And the nice thing is that we are running on the Intel platform and will be running for foreseeable future. So you can be pretty flexible with using Dockers, developing Dockers on your local machine, external, some IPC setup. And then, if it is possible, transfer a part of our entire work to the robot so it runs on our control box directly. That's the setup that we are envisioning right now. So why this ROS2 in UR framework? So we have quite a few good interfaces on the robot. They are good for what they were made for, but we have observed that some URCAP vendors, more advanced URCAP vendors, even like Gripper URCAP vendors, usually have to use more than one interface to realize their applications, to make it easier for customers to use their hardware. So they have to learn our custom protocols, usually more than one, and learn how to integrate it, and not only integrate it, but integrate it properly so it works 24/7 for weeks and months without interruption. Then one more problem is that often, not often, but sometimes the multiple URCAPs for multiple vendors are conflicting with each other. I will not go into the details, but we have some shared resources on the robot that URCAP developers are using, and that is a problem. Our protocols are great, but they are not. They are not quite scalable into securing them. You can right now on the robots either enable or disable them, and otherwise it's very hard for us to provide the proper security measures around those protocols, like wrapping them in some secure protocols. So I think this will be the last, or almost the last advantage, is that QoS introduced in ROS2 should help us with managing the bandwidth of data. Our real-time interfaces are, as the name says, real-time, and if you register for a lot of data, then even if the data is not changing, it will be taking bandwidth and will be transferred. So the QoS is helping. I will get back to that a little bit later when I will be talking about real-time data. Oh, diagnostics, this is definitely the last one, ROS2, and has a lot of nice tools like ROSBAG, RVs for visualization, diagnostics, plot juggler, and this would allow us not to develop those tools ourselves in-house and use whatever is available in ROS for diagnostics of the systems that are integrating even URCAP integrators. It's just also cool to work with ROS. There's a lot of academia people that are leaving academia, going to the industry, and then they are faced with some old, boring industrial protocols that they have to learn and they have to use. They forget about ROS. We would like to change that, so they will be able to use their experience from academia, from advanced applications that it's also done, for example, here in Fraunhofer, and be able to use it in the real-world applications. So a short introduction to URScript for those who don't know what it is. It is a low-level custom script developed by UR many years ago when UR was founded. And we have a front end that looks almost like a script, but this is just a front end. This front end code is under the hood translated to the script by the GUI and then sent to the controller for execution. So the controller is actually executing the script code. The extensions that we needed to add to the URScript to support ROS there were a few changes that we have to make. Like one thing was that ROS is using complex messages with multiple data fields and generally a simple data types inside, but this is a structured data exchange. So one thing that we have introduced to the script, and this is available not only for ROS developers, but for all developers or all robotic application developers, are structs which organize data into nice groups. There can be nested structs inside structs. This is all real-time hardened, so everything there is has to be used with great care, because those structs tend to take a lot of memory. Then can also put sequences. We can access structs with something that everyone knows, like dot operator. Can pass structs to our internal functions and also return structs. All our entire URScript is using value semantics, so has to be a little bit care about the copying of data. We don't have references, we don't have pointers. Everything is passed and returned by value. So that's a small introduction. And then how did we introduce ROS there? So we have created functions that are building handlers, or like registering using ROS API to create a topic. So in this case, it is topic test. And I will also come back to that a little bit later. It is created on the special namespace. We chose a namespace to differentiate between the robots. So if it is created like that, then it will be created in this particular robot namespace. And the standard message string type plus QoS settings that can be specified. We'll support all the ROS2 QoS settings. The way it works, when you want to actually get the data, there is one read method, and then most likely also this is a blocking method that will block until the data is received on the subscribed topic. So depending on the frequency, it can block for a longer time. It's not blocking the real time, it's blocking just the external thread. We use a separate thread for handling ROS communication to simplify things, and then most likely will be also some read method that is non-blocking. Then the same way for the publisher, topic, type, and QoS settings, and corresponding publish method. The test message in this case has to be a structure that corresponds exactly to the structure in ROS. The same applies for the received message, but the received message will get a structure that is automatically created. This structures can be created like anyway, but it has to correspond exactly to the messages. So exactly the number of fields. These are the limitations that we couldn't get around. Now another part is real-time data. So right now our robot is publishing a relatively big amount of information about its own state. So after we have also implemented a part where we are sending that real-time data over ROS. This is for some of the topics, it is sent at 500 times per second. So joint states is published 500 times per second. But some topics we leverage QoS settings, and something that is not changing very often, like safety status or robot mode, will be published only when it actually changes. The QoS that we have used also allows for a late joining. So if there's a node that is joining the ROS network late, then you can read the current robot state, current safety state. So now we would also like to pull you. This is something that we have in a beta stage. So there is a lot big room for improvements, for changes. but we would like to see two use cases of this interface. One is for industrial users, traditional industrial users, UR+ partners, OEM partners who are making quite advanced, more advanced applications. Plus, there is a nice blend between system integrators. If they get some people from who know ROS, they can build more advanced applications and integrate cameras, lasers, scanners, whatever has a ROS driver, plus algorithms, protocol converters. It would be nice to see also some uses in research community to leverage easy programming of the robots and ROS at the same time. So again, we welcome you to join the discussion and leave your email information, and then we can get back and discuss specific use cases. So the roadmap that we are planning for now, we are planning for the first release to have a kind of a ROS foundation with Docker containers for running own ROS contributions. We will supply functions in the script for publishing and subscribing. This will be a little bit of a limitation, but that's where we found most of the useful messages. ROS messages, there are many standard messages for publishing and subscribing, but there are no standard messages for services and actions. And right now, the way the ROS2 is designed, that has to be compiled and linked dynamically to the binary that is executing on the robot. So this is a challenge that it's a little bit hard to overcome for us for now. And our real-time data will be available. This is mostly for URCAP developers. In the future, we would like to ask you what you would like to have there, what are your applications, what would be useful in the ROS, what kind of messages, what kind of functions of ROS. So everything is coming in our future release. Polyscope is the name of our GUI software, and we are planning to introduce Polyscope version 6. Right now we are on the version 5. This will be a major release, and a few breaking changes will be introduced there. But the ROS that will be available there, it will be able to use the publish and subscribe functions directly from URScript. Message types that we will support in the first version are the standard message types that are available in the ROS2 repositories, and we have a fairly small library of UR custom message types for safety and program states, some things that we couldn't find a good representation in the standard message type repository. The robots are segmented by a namespace, so if there are multiple robots on the same network, then they can be each individually addressed. The namespace is based on the robot serial number, and most likely it will be possible to customize it, because why not? It's cool to have like a nice robot names instead of like 220, 17, 18, and so on. We'll most likely not have a real-time performance for the communication from the publishing and subscribing in URScript. Right now, everything has to go through an external thread that is supporting the real-time, that has an exchange queue from the real-time thread. We couldn't overcome some challenges in the middleware, where the middleware seems to be allocating some memory, and it's maybe in the future it will work. However, right now we believe that this will be fair enough. This is on the level of the performance of our XML RPC interface, which is also used by many customers. There is a beta program that we will start soon, probably either before Christmas or maybe soon after Christmas. And we are looking for beta testers, not only for Polyscope 6, but in this forum, mainly for beta testers for the ROS functions. So if you are interested, then you're welcome to request access to that beta program. And after probably a few discussions about the applications that you want to use it for, you could get the beta software soon in the next year. And that would conclude my presentation.